So let's look at section 7.2, hypothesis testing for the mean with the standard deviation known. So one things we'll have to do is with the hypothesis testing, we have to decide whether either to reject the null hypothesis or to fail to reject the null hypothesis. So what we end up doing is we make these decisions based on this p-value. So to use a p-value to make a decision in a hypothesis test, we compare the p-value to alpha, which stands for the level of significance. So if the p-value is less than or equal to alpha, what we do is we reject the null hypothesis. If the p-value is greater than the level of significance, then we fail to reject the null hypothesis. So let's look at example 1. If the p-value for the hypothesis is 0.0237, what is your decision with the level of significance? Well, first one is we have, so our p-value is going to be this 0.0237, and we're going to compare that to 0.05. So again, really what we're doing is comparing hundredths place to hundredths place. So if this is a 5 and this is a 2, we don't have to go any further than that. We pick up on that 0.0237 is less than, because remember the alligator eats the bigger one, or again, it points to the smaller one. That's a less than symbol. So that would be less than. So what would our decision be? Well, if it's less than, what we do is we end up rejecting the null hypothesis. So we reject H sub O. So look at example 2. Again, we're using the same p-value, but this time we're using the level of significance to be a 0.01. So we have this 0.0237, and what we're trying to do is compare that to 0.01. So to do that, we have a 2 here and a 1 here. So again, we have this 2 and this 1. So what we want to do is, how does the 2 compare to the 1? And that's going to be greater than. So if it's greater than, what that means is we fail to reject the null hypothesis. So fail to reject the null hypothesis, or H sub 0. So as we move forward into this assignment, what we're required to do is find the p-value for the hypothesis test. So they won't give us the p-value. We'll actually have to determine the p-value. So to determine the p-value, what we do is this. So after determining the hypothesis test, it's standardized test statistic. So again, this test statistic here will be, it'll be the z value. And the standardized test statistics corresponding area, do one of the following to find the p-value. So for a left-tailed test, p-value is going to be the area in the left tail. So notice how we have area under the curve again. So we've been doing this a little bit. For right-tailed tests, the p-value is going to be the area in the right tail. So for our two-tailed tests, the p-value is going to be double the area of the area of a tail on a standardized test statistic. That's a mouthful. So anyway, let's see if we can put that together. So finding the p-value for a left-tailed test. So find the p-value for the left-handed hypothesis test with a standardized test statistic of z equals -2.23. Decide whether to reject the null hypothesis when the level of significance is alpha equals 0.01. So again, the way we can do this is we can use our calculator and use what's called the distribution curve. So if we hit the second button and hit the vars button for the distribution, which is above it in blue, the area in the curve is going to be that number 2, normal cumulative distribution function. So we choose number 2 there. Now, with the left-tailed, our left bound is going to be negative infinity. In other words, we use a very big negative number. Upper bound is going to be the right bound, which is going to be the -2.23. Let's see if I can just type right over that. Oops, too many 2's. And then we don't have to change any other stuff there, because that's going to be, remember, when we do z-scores, the mean is 0, standard deviation is 1. That's how it works out for the z-table. Those don't have to change. So we let the calculator do it, and notice how we get the p-value to be then So it's going to be 0 point, so 0.012, and now we have to decide to keep the 8 or round it up. So it is going to round up to a 9. So notice how we are going to be in that spot there. That's going to be our p-value. So how does this p-value compare to the level of significance, which is this 0.01? So again, if we look at it, our hundredths places are the same. But notice that, remember, this actually can be, I can put trailing zeros there, but they don't add any value to it. So if I compare now to the 2 to the 0, we kind of see this 129 is bigger than this 100. So we pick up on, then this is actually greater than. So if it's greater than, what we pick up on is then we are going to fail to reject the null hypothesis. So we use h of 0 for that. So that's how, again, if we use the z value here, the area to the left is going to be this 0.0129, and we just found that using our calculator. Instead of, you can use tables, but we don't have to if we have our calculators available. So the next example is finding a p-value for a two-tailed test. So find the p-value for a two-tailed hypothesis test with a standardized test statistic of z equals 2.14. Decide whether to reject the null hypothesis when the level of significance is alpha equals 0.05. So again, to find the area of the curve, the 2.14 means we're going to be going to the right. So if I use our distribution curve, the normal cumulative is number 2. Notice our left bound, though, is going to be the 2.14. Our upper bound is going to be positive infinity, or we just pick a really big positive number, and 10,000 has been suggested. Again, we don't have to change those because, again, we're using the z table. The mean is 0 and the standard deviation is 1. So we end up within this area under the curve over here is going to be 0.0162. But notice how we have to find the area of both sides. So we actually have to double that. So this point, so this 0.016, now I got to decide what to keep with it. So notice how there's a 7 over here. So 1's got to change to a 2. But remember, we got to double that to get the p-value. So p is actually going to equal that. So if I times that by 2, that gives us then this 0.0324. And that's how we got this 0.0324. So we're matching what we have here in our example. So once we get our end of the curve, we got to remember, if it's a two-tailed, we actually got to double it if I'm using the z-score as our path. So how does 0.0324 compare to 0.05? So again, if we look at the hundredths place value, notice how the 5 is bigger. So that means that this is actually going to be less than. If it's less than, that means we reject the null hypothesis. So this would be reject h of 0. So that's our interpretation based on the p-value of this 0.0324 and how it compares to the level of significance, the 0.05. So the p-values for a z-test. So we get into what's called a z-test. So now what's going to happen is we won't know the z. They're not going to give us the z. We actually have to find the value of z. So z can be determined by, the z statistic can be determined by the sample mean minus the population mean divided by the population standard deviation, and that's going to be taking the square root of the sample size. So this is considered the standard test statistic for mu when the standard deviation is known for the population. Some things that have to happen, though, is for this to work, this has to be a random sample. And also, at least one of the following has to be true. The population is normally distributed, or the sample size is greater than 30. So at least one of those has got to be true. And recall that the population standard deviation divided by the square root of n, that represents our standard area of the mean. Or in other words, this is kind of considered the standard deviation of the means. They use this kind of notation here, where x bar represents the means. So we can use that formula there to find the z statistic, then which would allow us to find the p-value. So this is kind of where we're going to be going through, is this little pathway here. We have to make sure that it's normally distributed, or the sample size is greater than 30. We have to understand what the null hypothesis is and what the alternative hypothesis is. We have to know the level of significance. We have to find that z statistic, and then we have to find the area of the curve. And again, we're going to use the calculator instead of using the table there. And then we're going to use this p-value and compare it with the level of significance. And then we'll make a decision based on that, whether to reject or fail to reject the null hypothesis. And then we can kind of think more about what we actually are concluding as well. So that's kind of our thinking in this. So hypothesis testing using a p-value. So again, we have an example here. In auto racing, a pit stop is where a racing vehicle stops for new tires, fuel repairs, other mechanical adjustments. The efficiency is of a pit crew that makes adjustments can affect the outcome of a race. So we know that if you watch racing. A pit crew claims that its mean pit stop time for 4 new tires and fuel is less than 13 seconds. That's their claim. A random sample of 32 pit stop times has a sample mean of 12.9 seconds. Assume the population standard deviation is 0.19. Is there enough information? Is there enough evidence to support the claim? Or if the level of significance is this 0.01? And again, it says use the p-value. So again, the first thing is, since there's a sample size of 32, we can assume this is normally distributed. The next thing is we pick up on is our null hypothesis and our alternative hypothesis. So our H sub A, H sub 0, and our H sub A. So that's how they say the mean is less than 13 seconds. So what we're picking up on is mu is less than 13 seconds is going to be the alternative hypothesis. Because remember, the alternative hypothesis has to be the inequality, and the null hypothesis has to be the equality. So this would be, your mu has got to be the other side of that, which is greater than or equal to 13. That's our null hypothesis. So we have to pick up on that. So now now we understand what the actual null hypothesis is. But notice how this is the claim down here. This is what they're claiming. So now we actually go about deciding whether or not to keep the null hypothesis or reject it. So based on what we're seeing here, we probably would want to fail to reject it, but let's verify it with actual calculations here. So to find the z-score, it's going to be the sample mean minus the population mean divided by the population standard deviation divided by the square root of the sample size. So if I use my calculator, I can put that in. Let's see here, alpha F1, that looks better. So I have, what do we got here to start with though? So the sample mean was this 12.9 seconds minus the population mean, which was the 13. And we're going to divide that by the population standard deviation, which is the 0.19. And we're going to divide that by the square root of the sample size, which was 32. That gives us our statistic, our z-score. So we have 12.9 minus 13 Oops, didn't take my 1, did it? And if move to the bottom, I don't look right either. All right, let's clear that off there. Just crashed and burned on me. All right. I'm trying to do this without a mouse today and not having much luck. So 12.9 minus 13. You probably already got the answer, didn't you? Yeah, so move to the bottom. That looks better. Alpha F1 again, because the bottom's actually a fraction. So 0.19. And then move down and get square root of 32. So our z-score is going to be negative 2.98. Seems like they like to round that to 2 decimal places. And we do see that they do have the z-score negative 2.98. Notice how it said less than 13, so we know that this is going to be a left tail area. So remember, our area in the curve is always going to be from our inequality. It's going to be always coming from the alternative hypothesis is where that's going to be coming from. So now that we have our z-score, we can now find our p-value. So to find our p-value, we can use the distribution strategy. Remember, it's number 2. Now, to find a left curve, the left bound is actually negative 10,000. There is no left bound, so we use a really big negative number. And the upper bound is going to be that negative 2.98. Again, the mean and standard deviation don't change. So this gives us a p-value of 0.0014. So what we want to do is we want to compare that to the level of significance, which is the alpha. So how does 0.0014 compare to 0.01? Well, if we compare hundreds place to hundreds place, we see that there's a 0 there. That means it's smaller. If it's smaller, what that means is we reject the null hypothesis. So we reject h to 0. So that means we can't support greater than or equal to 13. But this leads us to notice how we have our A would be then the one that we look anyway, because we want the alternative hypothesis. So that kind of leads us to that we're supporting the original claim that's less than 13 seconds. So this kind of supports the actual claim in there since we rejected the null hypothesis. Okay. So let's look at example 5. Hypothesis testing using a p-value. So according to the U.S. Homes, U.S. heating equipment, let's back up here real quick before I do that. Notice that there's another way to do this problem without having to actually find the z-score. So we also have what's called a z-test. To do the z-test, we actually can bypass finding the z-score and doing the area of the curve. So the z-test is under stats. If I go to test, z-test is number 1. And we do want stats, so I hit enter there, make sure that's highlighted. Our mean was 13. Our standard deviation was the 0.19. So also this information is given to us so far. The sample mean was the 12.9. That was given to us as well. We're just inputting information into the calculator. The sample size was the 32. Now the catch is the inequality. Notice how we are left-tailed. That's going to be the alternative hypothesis, which is just less than 13. So we want the less than one here in the middle. We highlight that one. And then we continue moving on down to calculate. And notice that this gives us actually our z-score, negative 2.98, which we found the other way. This actually did it for us. Notice that this is actually going to be our p-value for this data. And notice how it gives us the same p-value. Actually, theirs goes up to 1.5, but we still get very, very close. Notice how all that plays out there, but the p-value is what we're looking for, is that, and that gives us the same thing. So instead of finding the z-score, the z-statistic, we can actually use the z-test, and that gives us all that without having to actually do all that extra math. So if I look at example 5, hypothesis testing using a p-value. So according to a study of U.S. homes and that use heating equipment, the mean indoor temperature at night during the winter is 68.3 degrees Fahrenheit. You think this information is incorrect. So you randomly select 25 U.S. homes that use heating equipment. And in the winter, and you find that the mean indoor temperature is actually 67.2 degrees Fahrenheit. From past studies, the population standard deviation is known to be 3.5 degrees Fahrenheit, and the population is normally distributed. So that's important because our sample size is not over 30. So they had to say normally distributed for us to move on. Is there enough information to support your claim at a level of significance of 0.05? Again, we're going to use this p-value. So again, it is normally distributed. So notice how we have to kind of create our null hypothesis and alternative hypothesis. Notice how they're saying the mean indoor temperature is 62 degrees. I'm sorry. What they're saying is the mean indoor temperature at night is 68 degrees Fahrenheit. Remember, that's the equality. That's going to be the null hypothesis. That's going to be 68.3, which means our alternative hypothesis is going to be the opposite of that. So that's actually mean is equal to that, mu. So mu would not equal 68.3. So let me see if I can clean that up a little bit with my eraser. Try that again. So when it's not equal to, that means it's a left and right concept. This tells us that we're going to do a two-tailed normal distribution. So here, they actually have us find the z-scores, but we're going to bypass that. So we're actually going to use the z-test here to do this problem. So if we go to stat, we're going to put this in there. Stat's fine. Our mean was actually the 68.3. That was what was given. It's the population. The population standard deviation was the 3.5 degrees. When we did a sampling with those 25 people, we discovered that the sample mean was 67.2. The sample size this time was 25, but like I said, they said it was normally distributed. We're okay there. And notice how we now have our alternative hypothesis is actually the not equal to. So if we calculate, so again, notice that this is our claim right here. This is what we claimed. Come here. So this is our claim. So if we look at our p-value, notice that they actually give us the full p-value of, we don't have to do the doubling here. That's how they multiplied the z-score by 2. And we got this 0.11, so 0.1164, we're already there. So we don't have to do any math there at all. This gives us our p-value of 0.1161. So what we're trying to do is figure out how does 0.1161 compare to the level of significance, which is the 0.05. So we pick up on, as far as we have the hundreds place there, we have this 5 here and this 1 here. So how do they compare? Actually, we have an 11, I should say, because we got a front in there. We actually got 11. 11 is bigger than 0.05. So that means this is a greater than. If it's greater than, what this means is we fail to reject the null hypothesis. So if we don't reject the null hypothesis, then we're accepting the claim to be true. So we're holding up on that. So we're not rejecting it. So we're okay with that 68.3. We agree with that based on the data. Okay. So last thing we'll have to do in our assignments is we'll have to use a graph to determine whether or not to reject or fail to reject the null hypothesis. So what they pick up on is, as far as this goes, is we want to pick up on the level of significance, which is going to be alpha. Remember, alpha kind of is associated with the p-value. So this also represents what's called the area in the curve. So we want to determine whether the test is left-tailed, right-tailed, or two-tailed. And then we want to find the critical value z. When the hypothesis test is left-tailed, the z-score that corresponds to the area of alpha. So that's just straight up. But then if we want to find right-tailed, the z-score that corresponds to the area of 1 minus alpha. So it's going to be kind of the right side. So we'll be using that to find the area. And then if it's two-tailed, then we have 1/2 alpha and 1 minus half alpha. Some of the things to pick up on is, we're doing the area in the curve, but notice how there is symmetry involved here too. So if I find the left area, the right area should be symmetric to it as well. So if I find a left z-score, that right z-score should be symmetric to it. So we can use symmetry with respect to this as well. So let's see where this takes us at. So find the critical value of a left-tailed test. So the level of significance is this 0.01. So what we have basically is we're looking for the z-score where the area of the curve is going to be this alpha, which is going to be this 0.01. So using our calculator, see if we can find my calculator again. I think I've done misplaced it here. So let's see if I can get it to come back out here. All right. Let's see if we get this thing to come over. And come on. We're getting there. All right. Let's get this to be a little bit smaller. I got the pause there. Just staying want to cooperate. So as I said, we have this critical value for a left-tailed test. So they gave us this alpha, which is going to be the area of the curve, and we're looking for a z-score. So remember, we can use the distribution and go backwards on this. So if we hit second button and hit distribution here, notice that if we use the inverse norm, that works if we know the area and we're looking for the z-score. So if we go down number 3, the area is going to be this 0.01. And again, notice how it tells us left tail, right tail, and stuff like that. So we have some shortcuts there. So if we do that, notice how we get the z-score of negative 2.33 as our answer there. So our z value is going to be negative 2.33. So again, the rejection region is going to be this less than this negative 2.33. So our rejection region is going to be z values that are less than negative 2.33. If they are, then we would be rejecting the null hypothesis. So find the critical values on a two-sided one. So our level of significance is this 0.05. So that's our area. Now remember, this area represents the total area. So so remember, this is going to be 1/2 alpha over here, and this is going to be the other 1/2 alpha over here. It's going to kind of be split. So what I'm looking for is this z-score here, and I'm looking for this z-score here. I'm looking for this here and this here. So to do this, we need to divide the alpha by 0.05 by 2. That's going to give me 0.025. So our alpha we're going to use, or our half alpha, if you will, is going to be this 0.025. So what this is going to allow us to do is find the area under the curve over here on the left. So if I use my distribution, we can kind of figure that out. Number 3. So again, we're going to use 0.025. If we hit enter, yep. So we're doing a left side tail. That's fine. Hit enter. And that's going to give us then this, so our z-score is actually going to be this negative 1.96. So if z is less than negative 1.96, we reject. Or if c is greater than 1.96, we would reject. So also they kind of said on a two-tail, they gave us another way to do it, which was go 1 minus 1/2 alpha. If I do 1 minus 1/2 alpha, so 1 minus 1/2 alpha, that's going to give me 1 minus 0.025. So what is 1 minus 0.025? That's going to give me this 0.975. So if I do that, that's find the area from the left again, because that's the area from the left. So if I do that normal distribution, if I do number 2, if I do again, oops, number 3 actually, normal distribution, inverse norm is number 3. Lost all that. Let's clear that out and make that go away. And then try that again. So number 3. Sorry, we're going to say 0.975. And then they're still going from the left if I do that. Hit enter. And I'll see how that gives me 1.96. So again, I can do that, or I can just use symmetry to get the right side z-score. Get back over there. Okay. All righty. So that's kind of what we were doing here, is doing this. So the blue is kind of the rejection area, and the yellow is kind of fail to reject. So the blues are rejection areas or rejection reasons and stuff like that. So we can kind of pick up on that. So notice how if it's a left tail, we got less than, a right tail, we got to be greater than. And then notice how we have 2, a less than and a greater than, since we have 2 tails there. Let's see how that helps you out there as you move forward into hypothesis testing.